Okay, let's start. Yeah, November 2026 one. And let's start with the first question. It says, it is known that on average 1 in 300 flowers. So I'm talking about the probability of success. 1 in 300 flowers of a certain kind are white. A random sample of 200 flowers is taken. So I'm taking 200 flowers and it's 200 using approximating distribution. So right now this distribution is binomial and P is 1 out of 300 and N is 200, which is used in approximating distribution to find the probability that more than one flower in the sample is white. So using an approximate distribution means lambda converting it to a Poisson distribution. This gives me 2/3. So probability of more than one flower is 1 minus probability of 0 and probability of 1. Okay. Uh, that gives me 0.144. Okay. So I justify the approximating distribution used in part A. So generally हम binomial से normal तब convert करते हैं when lambda is greater than 15. Sorry, lambda in this case binomial है. So when n is large, which means that n is greater than 50 and p is small. And in this case is 200 and p is small का मतलब होता है p is less than 0.1 or 10%. P in this case is 0.0033. Okay, so that's your justification for using the Poisson distribution for a binomial distribution. The probability that a randomly chosen flower of any white kind is white is 0.02. A random sample of 150 of these flowers is selected. So again, I'm selecting a row using approximate to find the probability that the total number of white flowers in the two samples is less than 4. So again, what I have to do is I have to combine the probabilities. The first lambda that I got was 2/3. The second lambda that I'm getting is 0.02 into 150. That means that three. So combined lambda is 2/3 plus 3. That gives me 11 over 3. And I'm asking you to find the probability that it is less than 4. So I'm asking you to find the probability of 0, 1, 2, and 3. So I'm going to add up e power minus 11 over 3 plus 11 over 3, e power minus 11 over 3 plus e power minus 11 over 3 into 11 over 3 square over 2 factorial plus okay. Should be 0.5011. Okay, that was question number 1. Question number 2. In a survey, a random sample of 250 adults was asked to fill a questionnaire about their travel. It was found that 102 adults in the sample traveled by bus. Find an approximate 90% confidence interval for the proportion of adults So I'm asking you to find the confidence interval of proportions. So इसका फॉर्मूला होता है कि अगर पॉपुलेशन प्रोपोर्शन का आपने कॉन्फिडेंस इंटरवल निकालना है, so it's PS minus Z into root of PQ over N, where this is also S, and this is PS plus Z into root of PQ over N. Okay, so PS is therefore 102 out of 250 minus Z value. Now 90% confidence interval means that I have to look at the Z value for 95%, which is 1.645. So 1.645 into, now since the numbers are large, let me just calculate this in decimals. This is 0.408 or 0.593. 0.408. Okay. Point 357 or 0.459. Okay, those are the correct answers. Then says the survey included a question about X dollars spent on travel. The results were summarized as follows. Find unbiased estimates for population mean and variance. Unbiased mean is 50460 divided by 250. 201.84. And unbiased variance is 250 over 249 into 19854,200 divided by 250 minus 201.84 squared. Okay, any questions so far? Three, two, three, two. Okay, rounding off to three significant figures would give me say 800, which is what's given here. Then says the counselor wanted to select a random sample of 20 houses in Fromley. He planned to select the first house on each of the 143 streets in Fromley. Explain why this could not provide a random sample. There are various ways of answering this. Whenever you are indicating that something is not random, you should indicate where the bias is coming from. And in this case, the bias is towards the first house in the street. Okay. All houses do not have an equal chance of being selected. Okay, let's see what the marking scheme says. It says every house doesn't have an equal chance of being selected, or most houses have no chance of being selected, or other similar houses in the street with few houses are more likely to be selected, not just biased. or without explanation. So you need to say that it's biased and with an explanation. Okay, then it says the masses in kilograms of female and male animals of a certain species have the distributions this. So this is from linear combinations. Find the probability that a randomly chosen female has a mass that is less than half the mass of a randomly chosen male. So you move everything to one side and you say that you created a new variable called difference, which is f minus half m. Difference will have a normal distribution. F is 102 minus half of 170, comma, then 27 squared plus half squared of 55 squared. This is a question on multiples. That gives me 17. And 1485.25. So the difference has to be less than 0. So I'll convert it into a z value. For 6704. Okay, let's check. It's 330. That is what I have to if I round off to 330. They've done it in different way instead of having zero point 0.5. In this case, they have 0.5. And this gives this converted into a different sort of difference, which is absolutely fine. Okay, and this is the diagram shows the probability density function of this. Elsewhere f of x equals to 0. Express k in terms of a. So this entire area must be equals to 1. So I'm going to say that ka equals to 1. So k is 1 over a. Given that variance of x equals to 3, find a. So I'm going to say that variance of x is basically x squared f of x dx minus expectation of x squared. And this has to be integrated over the entire limit, and this is basically equals to 3. Okay. Now, x squared f of x. So in this case, f of x is basically y equals to k. So I'm going to say that this is x squared into k. And expectation will also be x into k. So this is basically equals to 3. So this becomes x cubed over k over 3 minus x squared k over 2. And the limits are 0 to a. Okay, I know that I can replace k with 1 over a, but I'm going to do that towards the end when I've simplified everything else. This becomes a cubed over k over 3 minus a squared k over 2. minus 0, because x when plugged in as 0 gives me 0 entirely. Now I'm going to plug in k as 1 over a. Okay, this becomes a squared over 3. I have a lot of space. Minus a over 2. Pick a common denominator. This becomes 2a squared minus 3a equals to 18. Okay, putting this on my calculator. Let me check. We've done something wrong. My bad. This was supposed to be squared. 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 So squared. A squared over 3 minus a squared over 4 equals to 3. So 4a squared minus 3a squared over 12 equals to 3. 6. 6. Okay. Question number 5. It says the number of absences per week by factors has a distribution of this. Find the standard deviation of the number of absences. So variance is the same as the mean. So variance is also 2.1. Standard deviation will be root of 2.1, which gives me 1.45. Find the probability that the number of absences in a 2-week period. So lambda was 2.1 per week. So lambda is then 4.2 for 2 weeks. When I ask you for at least 2, I'm asking you for greater than or equals to 2, which means 1 minus probability of 0 and probability of 1. 1 minus e power 4.2 minus 4.2 e power minus 4.2. Point. Okay, find the probability that the number of absences in a 3-week period is more than 4 and less than 8. So 3-week period gives me 2.1 into 3, which is 6.3. And I want more than 4, but less than 8. So I'm asking you to find the probability of 5, 6, and 7. So e power minus 6.3 into 6.3 power 5 over 5 factorial. E power minus 6.3 into 6.3 power 6 over 6 factorial. Okay, so putting this on a calculator. Do you have the calculation come now? .455. Okay, sorry. Thank you. Okay. Following a change in working conditions, the management wished to test whether the mean number of absences has decreased. They found that in a randomly chosen 3-week period, there were exactly two absences. Carry out the test at the 5%, 10% significance level. So this is hypothesis testing. So I have to write down my null and alternate hypotheses first. They are saying that the management wish to test whether the mean number of absences has decreased. So yeah, in a chosen 3 week period. So I can take this lambda. I'm saying that the lambda was first equals to 6.3. Now they want to test whether it's less than 6.3. There were exactly two absences. So this is my test statistic. I'm going to calculate the probability of x less than or equals to 2 and say that मुझे 0, 1 or 2 की probability निकालनी होगी. So e power minus 6.3 plus 6.3 e power minus 6.3 plus 6 point, e power is minus 6.3 to 6.3 squared over 2 factorial. You're telling me the probability is 0.498. This is less than the significance level. Therefore, H naught is rejected. No evidence to suggest, sorry, H naught is rejected. There is evidence to suggest that the mean has decreased. Okay. State with the reason which of the errors type 1 or type 2 might have been made in carrying out the test in part B. Type 1, because H naught was rejected. Okay. Then says the time in minutes for Amjan's journey to work on Mondays as a mean 38.4 and standard deviation 6.9. Find the probability that Amjan's mean journey time. So I'm asking you for the probability of x bar less than for a random sample of 30 is between 38 and 40. So x bar की जो distribution होगी वो होगी 38.4 and 6.9 squared divided by 30. So I'm going to convert both sides to z values. Okay. Right. 318. 6 Okay, then it says Anjan wishes to test whether his mean time is different on Tuesdays. Okay, he chooses a random sample of 30 Tuesdays and finds that the mean time for these 30 Tuesdays is 40.2. Assuming that the standard deviation for this journey time is also 60.9 minutes, stated the reason whether we should use a one tail or a two tail. Two tail because Anjan is testing if the mean time is different. He is not sure whether it has decreased or increased. Okay, and then it says carry out the test at the significance level. So mu was 38.4. I'm not sure what it is right now, so I'm going to say that it's not equals to 38.4. Then I use a two-tail test. I draw my critical region first. 5% on both sides. Okay. I read out my value. 95% is 1.645. My test statistic is 40.2 and it's 30. So I calculate my z value. Okay, this is in my acceptance region. So H naught is accepted. No evidence to suggest that it has changed, right? Okay, just draw this when you have so that मुझे comparison की बात लिखी हुई है method और जो mark है ना this method mark the examiner should know that what you've compared it with. Okay, explain whether it was necessary to use the central limit theorem in B2. Yes, because distribution is unknown. Okay, that is the end of this exam. Let's look at the next one.